moving ahead, this problem is based on single phase induction motor which draws 12 megawatt power at 0.6 lagging power factor. Okay, and a capacitor is connected in parallel to improve the power factor of the total system. That system consists of motor and capacitor. Okay, to improve the power factor, we added capacitor along with the motor. We all know that capacitor is used to improve the power factor along the load. So now it is assumed that real and reactive power drawn by the motor remains the same as it was drawing earlier. Okay, so real power will still be 12 megawatt and reactive power will still be whatever was drawn initially from the source, that will be same. Now we will have to see how much the reactive power delivered by the capacitor now. Okay, now to improve power factor, capacitor, we all know it supplies reactive power. So we will see how much reactive power is supplied by capacitor. Okay, so earlier 12 megawatt power was supplied from the source, or a single phase induction motor was taking. So for that purpose, after this single phase induction motor was taking this power, and when this power got converted into reactive power, so we all know Q by P is equal to tan phi. So uh, if we know P, that will be 12 megawatt. So Q will be 12 tan cos inverse of 0.6. So that would come out to be 16 MVAR. Okay. So now we know what was the initial reactive power being supplied from the source side. After that, we will compute how much reactive power was delivered by the capacitor. Okay. So now if we need to compute the real and reactive power, so uh, it is written that real and reactive power drawn by the motor remains same as before. Okay, so it will remain same as before, but how much would be supplied from the capacitor? So 12 megawatt is the earlier power, that will be same. And now to maintain this zero point 0.8 lagging power factor, how much reactive power would be drawn from the source? So that will follow the same formula, and it will come out to be 12 into tan 36.86, and that will give us the 8.996 MVAR. So now this much reactive power would be supplied from the source. So remaining reactive power will be supplied from the capacitor. Okay. So from 16, if we reduce this much power, that will be supplied from the capacitor. So now capacitor is supplying 7 MVAR approximately. So that would be answer. Okay. So this was the system. So now the remaining reactive power was supplied from the capacitor. Okay.